All right. Welcome back. So I'm just quickly going to start. Um, right. Hey, hi, Shop. Um, welcome to the stream. So today's day 41. Um, getting closer to day 100, right? Okay. So, from the description, um, I have something else to talk about, which is circular arrays. But before I talk about circular arrays, I would like to, solve this question here, the browser history question. So let's do that first, right? And then I'll just go ahead and solve and talk about circular arrays. So I'll read the question. Um, I'll read the question and then I will I will try and explain what the question is really about. And yeah, so from there we can, you know, move on to the next topic. Okay, so that's about it for now. So here's the question. It is LEET code 1472. Um, oh, tell me about yourself. Okay, I'll have an open discussion at the end of the session, so hang in tight. Yeah. Okay, so let's carry on with the question. So this question is on stacks, right? So it's going to be a stack related question. Yes. I mean, a stacks, arrays, linked lists, whatever you can use to solve this question. But since it has stacks in it, um, I just chose this to work on it, right? So let me read the question. You have a browser of one tab where you start on the home page. You can visit another URL. Get back in the history number of steps or move forward in the history number of steps. Okay, let me read that again. I didn't read that well. So you have a browser of one tab where you start on the home page, right? And you can visit another URL. Get back in the history number of steps or move forward in the history number of steps. Implement a browser history class. Now the browser history class is going to be like this. So this is the class. The class takes the home page, initializes the object with the home page of the browser, right? A visit URL method. Visit URL from the current page. It clears up all the forward history. Okay. A string back, right? Okay, sorry, this returns a string. A back is also a method. Back, basically go back in history. Move steps back in history. If you can only return x steps in the history, and x and steps is, sorry, move steps back in history. If you can only return x, or if you can only return x step in history and steps has to be greater than x, you will return only x steps. Return the current URL after moving back in history at most steps. Forward, this forward method as well. Forward, move steps forward in history. If you can only move forward x steps in history and steps is superior to x, you will I don't know why they try to make this complicated. It's just too much words for this, right? Even reading it is just somehow, but anyway, I'll just read it anyway. So let me read it again. Move steps forward in history, right? So this forward method here, is to help you move steps forward in history. If you can only forward X steps in the history, if you can only forward X step in the history and steps is superior to X, you will you will forward you will forward only X steps. Return the current URL after forwarding the history at most steps. I'm sure every this is basically to simulate what happens when you visit a URL from a browser. So let me do this. I'll open a guest tab, right, and show you what that is. So basically, we want to simulate, how to operate certain things on a browser, right? Given the history, the amount of URLs visited, right? Moving back and forth between those two between the URLs we visited so far. So first of all, the the browser starts from the home page, right? So let's say we have a browser history like this. So we instantiate the class, or let's even move to the explanation. So when we create a new browser history, we'll start with the with a single history, or the home page, right? So let's say the home page will be this, right? Now when the home page is this, it means we can move back, right? We initialize the browser history like this by visiting one URL. So we are in. When we visit a second URL, it means we'll have a previous URL we visited, right? When we initialize the browser history class. So we can go from google.com back to LEETCODE, right? And then you can visit any URL from LEETCODE, right? When we visit any URL from LEETCODE after visiting google.com, from this point it will clear everything we previously visited, right? So let's say before I even go and show you how this works, what this back and forward really means is when you visit a URL for the first time, right? That URL is just going to be the visited one, so that will be your current page. But then when you visit another URL from that same page, right, we'll have a back history, right? And if we try to move back, we can only move back a certain amount of steps, right? So meaning if we had visited two URLs previously, we can only move back twice. But when we pass, when we try to move back 3 times, we will not be able to do that because we only visited three URLs so far. But for the forward one, the same thing happens. We cannot move forward to a URL we had not visited before, or we have not gone back from. So let me show you what that means. So let's imagine this here, right, is our our browser with the home page on it, right? When we visit a URL, let's say leetcode.com, like this, you can see the left tab of this browser here is activated, meaning we can move back to the home page, right? So when we click on this, we've moved back to the home page. But when we move back from the home page, because we visited leetcode.com initially, the forward button is now available for us to move forward to, right? So when we click on it again, we can only move forward a certain number of time, right? We can only move forward from how many URLs we visited or how many URLs we went back from. So when I visit another URL from here, I'll go to google.com, right? When I move to google.com, right, it means everything it means every URL that I've visited so far will be added to the back the back URLs or the back history, right? So that I'll be able to move back to those pages, those URLs. So from here, I can go back to leetcode.com, right? And then go back to the home page, right? And then after moving back, you can see I can still move forward, right? I can move forward only a certain number of times, right? From LeetCode, I can go forward to google.com. So this is how this works. And one other thing is, now we are on leetcode.com. Both our left and right tabs are active, right? So meaning we can move forward and we can move backwards. But if we visit another URL from this page here, while we are still here, while we still have another URL in our forward history, right? When we visit another URL from this page, everything that was in our forward history has to be cleared, right? If you read this here, it says visit URL from current page. It clears up the forward history, right? So when we visit a page here, I'll just say I'll say which page, books.com. Let me just say books.com. Now when I visit books.com, I don't know if this is okay, I should have done amazon.com or whatever. Anyway, when after visiting books.com, right, or this Barnes Noble, I don't know, after visiting this URL, you'll notice the forward history has been cleared, right? We can no longer go to google.com from this page here. Everything has been cleared. So we'll only have this here, and then leetcode.com, right? We can move back to leetcode.com and we can move back to the home page, right? So from the home page, we can still go forward. So the only time the forward button will be available for us to move to is when we move back in history, right? When we move back from a page. But when we visit a page from another page, let's say leetcode.com, and I go to github.com, yeah, then whatever page, the previous page I was on, whatever page it was, will be cleared from the forward history, right? We can no longer move forward to that page, and that actually makes sense in the sense that we are already we are in the middle, right? And we are trying to move to a new place. So whatever is in front has to be cleared for us to move to that new URL. And the same thing happens, right? So when you move backwards, whatever link we just moved from, or whatever page we moved from, will be added to the forward history, right? So we can still go back, we can still go forward, we can still move back here into LeetCode, and we can move back to our home page. And once we are at the home page, we only move backwards a certain number of steps, right? So far we've visited 2 pages, right? 2 pages like this. So this is 1, this will be 2, right? And this will be our last, which is the home page. But once we are on the home page, we can no longer move backwards, right? Because there's nothing else behind for us to move to. So we stop at this point, and this will be deactivated, which means we can move forward in history as well. So when we move forward, we are on this page. When we move forward again another step, we'll be on this page as well. So which is what the question is basically asking us to simulate or try and implement, right? So we have been given some classes, right? We'll be given some inputs, some boilerplates here for us to complete. So we have the constructor function here to instantiate our browser history class, and this takes a home page, and then the URL will visit. This will not return anything, but when we move back in history, we want to return a string, which will be the current page, right? So when we are here and we move back, it means we will land on a certain page, which is what this function says here. Or yes, so this, which is the requirement for this function here, and we can move forward in history as well, which is going to pages we've moved from, right? So for us to do this, we are going to use stacks, right? We'll use stacks to keep track of both our, back pages or back history and forward history. So here's how we're going to do it. So I'll say when we instantiate our class, right? When we instantiate the browser history class, we'll have to we'll have two, let's say, two stacks. So I'll call this, the first one will be the forward stack fs, which is simply an array. Okay, I'll represent it like this. I normally like I don't know, I'm used to representing stack this way, right? So that I can put stuff in it. It just gives me that idea that I'm putting stuff in a bucket. But you can also represent stacks with, what stacks are really is arrays, right? So we can just represent them with an array, but I can't close the array yet because I will need to add stuff in it, which is why I use something like this. So we will then have a back history stack. So this will go back in history, and yeah, our current page will be the home page. I'll say this current page here, I'll say the current page, right? This current page we are on. So initially when we open the browser, will be on a page, right? This will be our current page. Now I'll just say page here. This will be a page. Now when we visit a URL, when we go to a URL, let's say when we go to, I'll just put this here, or let's say we visit LEETCODE, right? LEETCODE. Now when we visit a URL, what happens is we move the previous page we were on, right, to the back history, right, to the back history tab. So whatever this is, we'll move here. So we'll have page here, and then we'll clear the forward stack. We'll clear it, right? We'll empty it to, already it was empty, so we still need to do that, so that anytime we visit a new page, we'll have to clear the stack. So we need to clear the stack every time we visit a page, and then we set our current page, right? We set the current page. I'll say cp current page should be equal to the page we have visited, or the URL. So this is the URL, so we'll put it here as the URL like this. So anytime we visit a page, we need to add the previous page we were on to our back history stack, and then we'll clear the forward history stack. Then we'll set the current page here to the URL that we just visited, right? So that's for visiting the URL. Let's say we visited let me represent this properly. I'm not sure there is enough space for me to do this. So let's say we are on a home page, right? Our home page, I'll call this page, right? Or current page. Current page is better. I'll say cp for current page. Current page is going to be home, right? Home, and we'll have our back history stack, which is going to be like this. Let me shift down a bit. I'll just say bs back history stack, or back stack, and forward stack like this, right? The forward stack is also going to be like this. Now when we visit a new page, right, let's say we go to LEETCODE.com. so I'll put visit here, or just call this a URL LEETCODE.com. Now what needs to happen is okay, I don't need to type this all the time, so I'll just say when we visit URL, I'll call this URL 1, right? When we visit a new URL, what happens is we set whatever page we were on before, right, we push whatever page we're on into our back stack, right, or our back history stack, and then we'll move the current page to be this URL1 here. Now, at that point, when we begin the first, visit to a new URL, the forward stack will be empty. But we still need to make sure that every time we visit a new page, we clear the forward stack. So we'll clear the stack. I mean, it's empty now. So let's just do that. So I'll take this, right? This new URL1 will come here, right? And sorry, not that. The home page here, this home here has to be moved to the stack like this, and then we'll set our current page to the URL1, right? And this forward stack will still remain empty. Now, when we move back in history, right? When we move back to this home page, we want to come back to the home page from this URL1 here. What we do is we take this. Since we are moving back in history, right, it means we visited a page that we could actually move forward to after moving back, right? So we'll take whatever was here, right? We'll take whatever was here and we'll push it to the forward stack and replace this, right? We'll pop or remove whatever was here back to the current page. So our current page will be home, the back history stack will be empty, and then the forward history stack will now have the page we just moved from to the current page here. And this is what will happen if we visited more URLs, right? So when we visit another URL from this page, right, from the home page after reaching here, it means we will not have anything else to move to, right? Let me show you that how that works. So currently you can see the forward history is active, right? When I move to, let's say I want to Google Amazon, when I go to amazon.com, right, my forward history is now cleared, right? I can no longer move forward to whatever page I was previously, right? Because I was at a certain, let me do LEETCODE.com, right? Let me visit a couple of pages first, right? I'm on LEETCODE.com. I can visit github.com. So I'll just say GitHub. Oh Christ, github.com. Oh, come on. github.com, right? I've visited 2 pages so far. Now when I move back in history, right, I'll come to leetcode.com and then I'm back on the home page. But when I visit any page from here, right, let's say I go to google.com. Yeah, let me use google.com. google.com, like this. Whatever page I visited previously, which I could, I would have had the opportunity to move to, right? Let me just quickly move to those pages again so I can move forward. I can press the forward button and move forward in history, right? I can go back, but since I'm on the home page and I want to visit another page from this page, the forward history will be cleared, right? So let me go to google.com and you can see my forward button is no longer active. I can no longer go to LEETCODE. I can no longer move to GitHub. So those pages or URLs are now removed from my stack or forward stack. So any page we move to or any page we visit, when we have any page we visit on our browser, right, we need to clear the forward stack each time, right? So for us to do that, when we are on the home page and we want to visit a new URL, we'll clear the forward stack, push in the old page onto our back history, right? We'll clear the forward stack like this. I'll just take this, clear this forward stack, move our home page to the back history, and set the new URL that we want to visit to the current page like this. So which is exactly what needs to happen, right, when we implement the visit method, which is this one here, this visit. So the next thing to do is the back, right? When we move back, it's basically removing whatever we had. You know, we set the current, when we are moving back in history, we'll move the current URL to the forward stack, and the page that is on top, or the URL that back stack, moves to the current page, right? It moves to this part here, and then we just pop the value from the back stack here. We just remove the value, set it to the current page, and whatever the current page was, we'll just put it as our forward stack. And the opposite happens when we move through the forward history as well. So when we are going forward in history, we'll set the current page, push the current page back. The current page will just be the URL we are currently on, and this will happen for any amount of pages we visited or URL we visited so far. But one thing we need to be careful of is how many times we can click on this forward button or this backward button until it becomes disabled, right? We can only click as many items or many URL we have in the stack. For instance, in this case, we'll only stop at 1, right? We cannot move more than 1 back in history. We can only move 1 in history because we only have 1 home page in our back stack. So, and for us to move forward in history, we cannot move forward in history because there is nothing in our forward stack as well. So yeah, and that way we'll be able to implement the second and the third and the second, the second and the third methods, right? So I'll copy this and paste it in my code editor as usual for me to explain how this will work. So this is 1472, right? So I'll just say create a new file. This is a stack question, so I'll put it in the stack folder, right? New file. I'll set this to leet dash is it 1275 1472 1472, right? And the title is, I think, browser history, design browser history. So I'll call this browser history. Come on. So I'll put this here, right? The reason why you see these errors here is just because there's nothing there. So if I put a pass there, it will clear these errors. Come on. Pass and pass it, and then pass. Okay, so this will make things a bit easier. So we need to create an instance of our we need to create the back history or back stack and forward stack. So here's what I need to do. I'll set the current page, right? I'll say self dot current page. I'll call this current page and set to the home page. So this will be the home page, right? And then we'll say self dot because I'm using self dot because I want these variables to be accessible throughout or anywhere in the methods that belongs to this browser history class. So I'll call this will be the back stack. Let's say this is back stack, and I'll set it to an empty array at first. Self dot forward. Okay, I don't know about that. Forward stack, and I'll set this to an empty array as well. Now when we visit a page, 2 things have to happen. So first of all, there are 3 things that happen when we visit a new page. We first of all set our back history to the current page. So we know we had a current page initially, which is the home page. So our self dot current page, sorry, self dot back stack, then we'll append the current page to it. Append the current page, sorry, self dot current page, and then we will set, after adding the current page to the back stack, we'll set the current page, sorry, self dot the current page to be equal to the URL we just visited, right? And we'll do self dot forward, the forward stack, right? We'll clear it. So let's just clear it like this. So this will clear the stack, right, that we just got here. It will clear the forward stack, add the previous page to the home, to the back stack, and then the current page to the URL. Now, how do we move back in history? Well, we are moving a certain number of steps, right? So we can move based on how many active pages we've moved away from or we've visited. So let me say this will be an iteration. So for I don't need the index, right? So I'll just say for dash in range of steps. So steps is going to be an integer, right? So we'll move from 0 all the way down. Now when we reach so when we are moving back in history, right, we want to set our forward, so self dot forward the forward stack, right? So since we are moving back, the page we were on, right, the current page goes to the forward stack. So forward stack dot append, right, append the current page, so self dot current page, and then we can, we'll then add we'll set the current page self dot current page to be equal to we pop a URL from the stack. We'll pop a URL from the stack. We'll remove one URL from the back stack. Sorry, we'll remove one URL from the back stack and add it as the current page since we are moving backwards, right? So we'll do self dot backstack, right, dot pop, right? So we pop one URL from the top of the stack, right? And yeah, so that's about it. That's what we do here. Now there is one thing we need to be careful of. What if we had visited, let's say we had visited just one page, right, and we want to move 2 steps backward. As it is now, I can only click on this back button once, right? I cannot move twice. I cannot move more than 2 times. So which also means when I move back, I'm removing the current or the previous page from the back stack, right? From the back stack. So when I remove and there is nothing in the stack, I should not be able to click this button again. I should not be able to go back in history. So we need to also, be careful of that edge case as well. And here's what we need to do. So we'll say if not so meaning the current page is going to be empty. If not self dot backstack, which means if the backstack is empty, right, then we need to break the loop, right? Otherwise we keep moving forward by adding the current page to the we keep moving backwards by adding the current page to the forward stack and removing one page from the back stack and adding it and setting it to our current page. Now how do we move forward? It's just going to be the same thing, right? But this time around we'll just remove from we append the pages, this current page, to the back stack instead. So let's say this is going to be for in range, the length of steps, right? Length of steps. Then we'll say, oh come on, we'll say if not self dot forward stack, right? We want to break. Otherwise, we'll say self dot back stack, right? We want to append the current page to it, right? Self dot current page, and we will, oh sorry, not length of steps. Steps is just an integer. Sorry, this is going to be steps, right? And we'll do self dot current page will be set to self right dot forward stack dot pop. Okay, and okay, so we have some warnings here because this functions have to return a string. So I'll just do this after all the iteration. I'll just return the current page, self dot current page here, and the same thing will happen here. So return self dot current page as well. Okay, so yeah, with this we can, so what's this here? Expected blank line from 0. I don't know why this happens, but hey. Oh, expected blank line here. All right. Okay, so this is all we need to do, and we can move back. So let's test this out and see how it works. So I'll call this solution, and I'll set this to solution. This solution here, was it a solution? Oh, so it's no longer solution, it's browser history. Okay, so this browser history, right? And we'll instantiate it with one page. I'll call this, what should I call this page? I'll say default. I'll set this to default because this is our default page, right? And then let me just print the current page we are on. So print, instead of calling this solution, I'll call this browser like this, and say browser. Since it's an instance of the browser history class, it will have all the properties of that class. So browser, so the current page will be set to default, right? I'll call this default page here. So let's run this. Now you can see this is equal to the default page. Now let's visit a new URL. I can visit a new URL. I'll say browser dot visit let's say page 2. I'll just call this page 2, right? So this is a new URL that we are visiting, right? So when we visit this new URL, now page 2 becomes our current page that we are on, right? When we visit another URL from here, oh sorry, oh how did I do that? Okay, you can move stuff like that. All right, so let's visit another page like this. I'll visit 3 pages, right? So let's visit page 3 and page 4. Okay, so the current page will obviously be page 4, right? So let's move. Okay, you can see current page is got to page 4, but let's move back one step in history, right? So browser dot back, right? How many step? 1. So when I move back one step in history, right, my current page should be page 3. Now you can see page 3 here. I can move 2 steps backwards because you know I already have 3 pages at this point. So this will be page 2. If I move 3 steps. Now all of these pages will be moved away from, and I'll be on this page here, right? Now I'm back to my default page, but because I'm moving backwards, let me just print what is in my forward history, right? So let's see what's in the forward history. So this browser dot I'll call this forward stack to see what's in the forward stack. Obviously you see page 2, page 3, page 4 in the stack is going to be an array. Now you can see page 4, page 3, and then page 2 in it. So this is our forward history and whatever. So if we want to move forward, right? So let's print browser dot forward one, move forward 1 step, and I'll do this again. I'll print the back history as well. So I'll call this forward, and this will be forward. I'll call this forward pages, and do the same thing for the backward as well. So I'll put this here. So forward stack, backward stack, back stack. I'll call this back pages as well. So let's print this and see what's in it. So you can see we have default page as the only back page that we can move from, or we can move to after visiting page 2, right? So we can move back to default page if we want by moving just 1 step backwards, and for the forward page we can just move 2 steps forward, right? So yeah, and let's copy this and run it in LEETCODE for submission, and for submission, and so I'll just copy this quickly and paste it in LEETCODE for submission. Okay. Or another way is, do I need to type it all over again? No, I've done that already. So there's no need to. Oh, what have I done? So let me just copy this again. Right. I can copy the entire thing, right? Just, oh god, no way. I can copy the entire thing like this and just set it to here. Okay, we don't need this. We don't need his here. Right. Okay. So let's see what we have. Let's run this here. Hopefully there are no mistakes. Yeah, so this works fine. It's funny they used just 1 test case for this. I mean, what else would have happened? Alright, so that's it. Let me check the who is this person? Yeah. I don't know who this person is. But I don't think I want this kind of energy on my channel. So alright, so that's about it for this solution. And yeah, the next thing I wanted to talk about is hold on. The next thing I wanted to talk about is circular arrays. But before I do that, let me just quickly push this to GitHub. So git add, right, git commit /m. I'll push this. This is going to be LEETCODE 1472, right, 1472, and git push origin main. So the link to this solution is in the description, and you can have access to that on GitHub. All right, so that's about it. Let's talk about circular arrays, right? This is an interesting topic that I recently came across. I did not know. Oh, it's day 42. Really? Hold on. Is this day 42 or 41? Wow, it's 42. Okay, sorry. I did not know that. Let me change this to 42 and save. Okay, thanks for pointing that out. I really appreciate it. Okay, so where was I? Yeah, I was going to talk about circular arrays, right? Arrays that I worked on initially, and I did not understand how to move items around, even though you reach the end of the array, right? Let's say you want to get item at position 5. Meanwhile, this array has a length of 4, right? We want to, even at position 4, there's no item here, but the item at position 4 will go back to being the item at position 0, right? So let me show you what I meant by that. I'll copy this code here. I'll copy code and key. Yeah, so let me use code. I don't need key to explain this, so I'll just delete key for now. And then let's say I want to print an item at code. Let's take let's get the length of the array. I'll call the length n. N is going to be equal to the length of the code array, right? And then we'll just say code at 0. Code at 0 will be here. This code at 0 here is this. So let me just go ahead and print this. So code at 0 will be the first item in the array, since we start counting from 0, right? And the last item in the array, to get the last item in the array, will be the length of the array, n minus 1, right? So this will give us 3, and this is the third item in the array. So I'll print this. Now you can see 4, which is the last item in the array, is printed. But what if we want to get, we want item at position n, right? How do we do that? When I run this now, you can see this is out of range, right? This is, we don't have any item at this position, but there's a trick that you can use to get an item at that particular position, is by using the modulus operator, right? The modulo operator, right, will help us, so we divide the whatever value we have, right, by the length of the array. So let's say we divide this by n, right, n by n, and then we do this, right? When we run this, this will set whatever value we have that is not, or that is out of range, right? Let me remove this again. So when I run this, the value of this n here is equal to 4, right? Let me print it again. So I'll print n is going to be equal to 4. When I run this, this is 4, but the item at position 4 does not exist. The last item in the array is always going to be, the length of the array minus 1. But since we are trying to access this item here, we will run into this error, right? And for us to avoid this error and move back, so whenever we move out of range in the array, whenever we try to access an item that is not part of the array, this operation should move us back to the front of the array, right? It should take us back forward. It should take us back to position 0. So for us to do that, we use the modulus operator with the length of the array itself, right? So we put this like this, here, right? This will move the array back to the front, right? This will move this to 0, and when we run this now, you can see we have 5, which is the item we want. This is simply the length of the array. I'll just remove this. When we run this again, we'll move back in front, right? So this will give us back the first item we have in the array, right? And this is very useful, right? Because when we have, let's say I try to access an item at position 15, right? Now this would have been impossible, right? This would have been impossible, but because we are using the modulo operator, this will simply return an item at this position by counting. When we count beyond the array, it just goes back again. But under the hood, what this is doing is it's just returning the remainder of this division, right? So when I access this, when I run this, you can see item at position 15, right, would normally not exist in the array, because there's no item there, right? We don't have, this is out of range. But when we use the modulo operator with the length of the array, right, always the length of the array, this will give us the item we want it to return, a proper item. And this helps us, this gives the circular nature to arrays, right? So let's say even when we pass in 0, right, 0 modulo n, right, this will still return the first item in the array, right, which is 5. If we use a negative number, so let's say -2, for instance, right, it will still return the second item here. So this is very useful for us to use with circular arrays. And yeah, I think that is something I just wanted to point out. And there was a problem I worked on, which is I don't remember the day I did this, but it's the I think the bump diffusion problem, where we were supposed to get every item in front of a certain item in the array. So imagine we're asked to get all the value in front of 4. How would we do that, right? How would we get every item in front of 4? Well, one way to do it is to just say, okay, once we reach 4, right, every item in front of 4 will be 5, 7, and 1. But if we don't want if we don't want to iterate backwards, we can still continue moving forward by simply using the modulo operator, right? So we can go beyond this, right? So let's say n, right, or let's say 4 is at position 3, right? So let's say we want to access an item at position 4, right? So when we pass this, we'll get 5. So we'll get 5, and position 5, right? With the help of this modular operator, this will simply return back to the front, right? We have 7 here, and then when we go to this point here, 6, this will be equal to 1 here. So this will help us really get any item anywhere, right? So if we want to get every item in front of 7, right, in front of 7, it will be 5 first of all. It will be 5, and then 4, 1, right? And that would not be easy to do if you thought about it in a much straightforward way of using arrays, except you want to multiply or you want to double the size of this array and then just assume every item in front will simply be the double of the array. Otherwise, the modulo operator will help us do that, and it is very useful. You can get items anywhere. So let's go back to the bump diffusion problem. So the problem is really, let me explain it again. So you have a bump to diffuse and your time is running out. Your informer will provide you with a circular array code of length n and a key k. Decrypt the code. To decrypt the code, you must replace every number, right? All the numbers are replaced simultaneously. If k is superior to 0, the ith number in the if k is superior to 0, the ith number with the sum of the next k numbers, right? So we want to replace so when we are at this point, right, when we have an item at position 5, so I'll just do it this way instead of using this. So I'll call this, oh, somebody said keep up the good. Remember consistency key. Thank you very much. Thank you for your encouraging word, Captain. Yeah. Hey, my friend too is here, Emmanuel. Thank you. All right. So, okay. So let's say we have an array like this, right? This is our array, and we want to, so the bump diffusion problem says when k is superior to 0, so in this case here, right, when k is superior to 0, add every item in front of the ith item in the array or in the code array, right? So add the next k numbers. The next k numbers is three numbers in front of the current one, right? So when you think about this, in the first iteration, this is going to be almost easy to do. So let's say I here is equal to 0, right? This is fine, right? The next 3 items here are these. But when I is equal to 2, right? When I is equal to 2 and we are at this position here, I is here, right? How do we get the next 3 items? Because we know here at this point we only have 3 items and we can't go outside our array to get any more items, right? Which is one of the problem I had to deal with. I researched it a lot to find out about circular arrays, because at this point the array ends here. We don't have any more 3 items in front of 7. But when you think about it, right, according to the example, the third item in front of 7, right, will be 5, right? The third item in front of 7 will be 5, which means when we go out of this array, right, we want to go back to the front to get the third item, right? And the same thing will happen here. When we are at this position, we'll have to go out of this array and get 5 and then 7 as well, right? So we want to go out of, so let me remove this. So we are at this point, we are I here, right? We'll take this and that, right? We'll move back in front, right, to get the items in front, all the items in front of 7. And when I is here, we will do the same thing. We'll get this one, 5 and then 7, right? And so on. This is really what happens. So at this point, what are the 3 items in front of 4, right? The 3 items in front of 4 will basically be 5, 7 and 1. And with normal array operations, right, without normal array indexing, this will not be possible, because we know our array ends at this point here. Our array ends at the length of the array minus 1, right? Our array will end at this point here. So we can't get any more items. But with the modulo operator, right, with the modulo operator, even when we go out of bound, even when this will be 3, this would have been 3 at index 3, And where we get to index 4, right, the modulo operator will simply rotate our array back to the front, right? So at this point, whatever result we get here will be equal to 0, right? So we know item at 0 will be 5, and then when this is equal to, so this is 4 modulo 4, right, is equal to 0. 4 modulo, when we move 5 modulo 4, 5 modulo 4, which is the division of the remainder when you divide 5 by 4 is going to be equal to 1, which is here, right? And when you do for 6, right, 6 divided, the remainder is going to be 2, which is this one here. So every time we get a value that would naturally not be a valid index of our current array, we simply need to use the modulo operator and divide. We simply need to use that value with the length of the array, right? The length of the array together with the modulo operator to get the correct index, right? So when the array moves, when the index moves out of the array, when we use the modulo operator with the length of the array, it sets it back to the front, right? And so on. So this will always work for any value, right? Any value we are checking. So let's say here, there's, like I said, 6 would not have been part of the 6 would have been impossible to get as an index of this code array, but because we are using the modulo operator here, 6 will be set back to what, to 2, right? So item at position 2 is 1 here, right? And normally this would have been 1, this would have been 2, 1 and 0, right? So even when I put 60 here, although I will not know this off head, but the modulo operator will set this back to the correct index, right, which is 5, which is here, right? So that's how circular arrays work. And there will be cases where you'll be asked to rotate an array by a certain number of steps. You can still use this method to do that, right? So we'll look at that some other time. And that's it for this section, and thank you for staying throughout the session. It's been an absolute pleasure to have you guys here. And yeah, so we'll continue tomorrow with the 43, right? And tomorrow I would like to start a different topic, right? Although I'll keep working on stacks, linked lists, and stack, linked lists, arrays, questions. I think the next thing I'll need to do is, let's go to let me see. The next topic I need to move on to should be binary search, and I'll continue solving more questions on sliding window as well, 2 pointers. Yeah, so binary search from next week going forward. We'll see how that goes. The point is, this 100 days is to get really familiar with all of these topics, understand them, solve a couple of problems or questions, and just really familiarize myself with all of these topics in order for me to start solving more difficult questions as well. All right, thank you for staying through this session, and see you tomorrow. Bye.